Good day everyone, I'm Arlie Mark, and today, I'm going to discuss about sparse matrix. Sparse matrix are those matrices that have the majority of their elements equal to 0. In other words, the sparse matrix can be defined as the matrix that has a greater number of 0 elements than the non-zero elements. There are mainly two reasons for using sparse matrices. These are computation time. If we store the sparse matrix in a memory-efficient manner, we can save a lot of computational time to perform operations on the matrix. And storage. When we store only non-zero elements, we can save a lot of memory space that we can use for storing other data structures or performing other operations. When a sparse matrix is represented with a two-dimensional array, we waste a lot of space to represent that matrix. For example, consider a matrix of size 100 by 100 containing only 10 non-zero elements. In this matrix, only 10 spaces are filled with non-zero values and remaining spaces of the matrix are filled with 0. That means, totally we allocate 100 times 100 times 2 equals 20,000 bytes of space to store this integer matrix. And to access these 10 non-zero elements we have to make scanning for 10,000 times. To make it simple we use the following sparse matrix representations. Those are triplet representation and linked representation. But in this video we are going to focus on triplet representation. In this representation, we consider only non-zero values along with their row and column index values. In this representation, the 0th row stores the total number of rows, total number of columns and the total number of non-zero values in the sparse matrix. For example, consider a matrix of size 6 by 8 containing 9 number of non-zero values. This matrix can be represented as shown in the image. A sparse matrix is a matrix in which the number of zeros is more than the number of non-zero elements. If we store this sparse matrix as it is, it will consume a lot of space. Therefore, we store only non-zero values in the memory in a more efficient way. This is the code I use to check whether the given matrix is sparse matrix or not. That's all for this video. I hope you've learned something. Thank you for watching.